here, what's happening? So we know, everybody would know, like having a very basic knowledge, that there could be two kinds of sources, and we would name them as, say, voltage source or current source, correct? Okay, but really, if you're going to split the sources into types, they are actually referred to as independent sources and the dependent sources. Okay, so you have the independent sources over here, and then you have the dependent sources over here. What's the difference between the two? I can write down here. In an independent source, the voltage value does not change. Value does not change. It's constant. Value does not change, even when current and voltage changes in a circuit. Voltage. So value of the voltage will remain same, regardless of if there's a change in the voltage or current in a given circuit. In case of the dependent source, the value of the voltage or current will change. So the value changes when voltage or current changes. Okay, all right. Now let's look at the independent sources. Independent sources, we have the voltage source. And basically what it is, it's the constant potential. Constant potential, just a straight line. So say you have, usually for independent source, we use this sphere right here. And then if I mark it plus and negative, and if I connect some kind of, say, resistive load here, and if I try and measure, let's say this is C, this is D. If I'm trying to measure the VCD, so whatever the voltage over here at these terminals, so say if this is 5 volts, then VCD is also going to be the 5 volts, right? So the voltage over here, VCD, which is the output voltage, will not change, even though the resistive load may change or the current may change. It will always going to be the same. Okay, let's look at the current source, which is the second type of independent source. Same concept. Current source over here. So you have constant current here flowing in the circuit, and it does not changes. Constant current. Okay, a current source, independent current source. The symbol for that is you have this arrow which tells you the direction of the current, and then you have this resistive load right here. So the current will be the constant regardless of there's any change in the voltage across because of the load or anything else. Okay, so it's going to flow in this direction. Okay, now let's move on to the dependent sources. Okay, now I'm going to change the color here. So the dependent sources are further breaking down into 4 different kinds. One of the kind is referred to as the voltage, and it's okay if you don't fully understand all of it. So far what we have done in this course is voltage source. Okay, we haven't done any of the dependent source. Haven't even done current source yet. There's one example, current divider, where we will we'll have a current source, but mostly we have done voltage source, which is the independent source. But later on, when we go and study more stuff, we will be using dependent sources as well. So if you don't fully understand that, that's fine. You will start linking it up as we go along in this course. So the first kind of dependent source is the voltage controlled voltage source, also referred to as VCVS, voltage controlled voltage source. So what is happening over here? Now imagine that you have, go here. Okay, so this is right here, this dotted right here. This block basically connects the input part of the circuits and the output part of this. This is the input part of the circuit right here. This is the output part of the circuit right over here. Okay, so if I have these terminals A and B here, the voltage will be the potential difference between the two, VAB. If I have C and D over here terminals, the voltage, the output voltage will be the VCD, correct? This is your independent source. This is the diamond shaped looking thing, this is the dependent source, and this is on the left is the independent. Okay, the dependent sources are usually we use this diamond looking thing. Okay, so here VCD, which is the output voltage, VCD, which is the output voltage over here, equals to mu times VAB. Okay, and you might be wondering, VAB, remember, is this input voltage over here, and you might be wondering like what is this mu thing is. Remember, you have this block right here, okay, which basically connects the input part and the output part of the circuit. This block itself inside has some component, some electrical component. Those could be a combination of resistor, capacitor, inductor, or anything. Okay, so what this mu does, if I do the change or play around with this equation, mu would equals to VCD over VAB, correct? In other words, output voltage over the input voltage, correct? This is what we refer to as a voltage gain. Voltage gain. This mu represents the voltage gain. So what's happening over here? So say you have the small tiny voltage over here. You want to enlarge it, okay? Say you want to make it 10 times bigger. You want to get at the output, you want to get something like this, okay? So this mu comes in as an amplification factor. In some books, it will also symbolize as A in uppercase, okay? So if I have the voltage gain 10, so if the peak to VP here is 2, then the output, it will get 2 times 10, 20 V peak, okay? So this is what this source is doing right here, the independent source. It's actually going to amplify your input signal. Remember these independent sources right here, they don't necessarily exist in the real world. Okay, we make circuits such that they take the input signal from the power supply and they amplify it using some factor. In this case, it's going to be the mu, which is the voltage gain, correct? Okay, let's move on to the second type of the dependent source. This is going to be voltage controlled current. And you would know, as the name suggests, like over here, it was the voltage that was controlling the output voltage, right? So if the input voltage over here changes, your output voltage will also change. So that's why it's referred to as voltage controlled voltage source. Similarly, over here, what's happening? Voltage controlled current source. So this is VCCS, okay? And what's happening over here? You have this current flowing here. Okay, this is your dependent current source. Again, this is say A and B, so the voltage across this terminal would be VAB. This is C and D, so the current will be ICD. Okay, and if I am going to put it down into equation, your ICD, the current across these two terminals C and D, equals to GM times VAB. Okay, and I'll tell you how do I get that. Before I can um, play around with this equation and get the value, get the equation expression for GM would equals to ICD over VAB, correct? Now, from Ohm's law, you got R equals to V over I, right? What is conductance? Conductance is basically 1 over R, right? So if I, in this equation right here, GM equals to IC over VAB, that is referred to as conductance, right? So that's what GM is for. It's for the conductance. It's actually referred to as transconductance. GM is the transconductance. So here, the current here is controlled by VAB. That's why it's referred to as voltage controlled current source. If VAB increases, the current also increases. Okay, let's now move on to the third kind. Okay, because we have two parameters, voltage and current, so that's why we have 4 different kinds. Let's look at this one. The third kind is the current control voltage source. And then you have, this will be CCVS here. Again, you have circuit over here, the input part and the output part of the circuit are connected through this block right here. Okay, there is a current over here. Okay, so this is A terminal, this is B terminal, so I, A, B. This is your dependent voltage source in a diamond plus minus. So that is, say this is C and D. So there's this, the potential here would be VCD. So the equation that we will get from here will be your output potential, which is VCD, equals to R times input current, which is IAB. Because I'm using a lowercase, so I'll just IAB. Okay, what is R here? R is referred to as VCD over IAB, simple equation for the Ohm's law. This R is referred to as trans resistance. Okay, let's move on to the last kind of source. This is going to be current controlled current source. Current controlled current source, also referred to as CCCS. Okay, again, remember that you have the input part of the circuit and the output part of the circuit, which are connected like this. Say this is terminal A, this is terminal B, this is the current here will be IAB, and then you have the current source here also. Okay, so this is C and D terminal, say, so this will be ICD. Okay, so what would be the equation here? Okay, the equation here will be ICD equals to beta times IAB. What is beta? Beta is equals to ICD over IB, right? Okay, now beta is an amplification factor. Beta is referred to as the amplification factor. Okay, so say, I just want to, because I'm trying to conclude here, so I'm just want to give you one example here. Say you get a transistor, okay, you get a transistor, and this is the base of the transistor. So this is the base. Okay, you have a collector here, and then you have the emitter over here. Okay, at the base you are basically having a small current going in. Okay, think of speaker in your car. Okay, when you are trying to use that knob that you have, okay, you have that knob. If you try to rotate it clockwise, what happened, you are basically increasing the beta. You are increasing the beta over here, this right here. And when that beta increases, your ICD, which is the output current, increases. So you end up getting this. So if this transistor, say this is N3904, okay, this has a beta of 90. I'm just giving you a rough example. So this current will be magnified 90 times, and this will be 90 times bigger. Okay, so ICD here represents the output current of the circuit, and this is the input current. Okay, in transistor we say this is the base current, which is the input current, and the output current is the IC, which is the collector current. So just to summarize, like what kind of type sources we have and what we'll be dealing with throughout this course.